Assalamualaikum warahmatullahi ta'ala wabarakatuh. Welcome to another video on MCTA 2311 Signal and System Analysis. In this video, I will show you how to determine the transfer function of electrical system. Okay, when you are given the electrical circuit. Okay, for example, in this question, okay, you are given this electrical circuit, okay, which is the RLC circuit. VI is the input, VO of T is the output, okay, and the question asks you to determine the transfer function VOS over VIS for this electrical circuit. Okay, so if you see the graph or the circuit, you are given in terms of T, in time domain, but the question asks you to determine in S domain, okay, which is the frequency domain. Okay, so you can do this using Laplace transform. Okay, so if we analyze the circuit, we can see that we can apply the Kirchhoff's voltage law, okay, to determine the equation to represent this circuit. Okay, so if I draw a loop here, okay, and this will be my first loop, and I will name the current as I1 of T. And if I draw another loop here, this will be my second loop, and I will name the current as I2 of T. Okay, so if I write the equation for loop 1, I will have and let's call this R1, let's call this R2, let's call this inductor as L, and this capacitor as C. Okay, so this will be easier when we first write the equation. Okay, so following this loop, okay, I will have first VR1 of T plus VR2 of T, okay, equals to VI of T. This is for the first loop. For the second loop of loop 2, okay, so following the arrow here, I will have VL plus V capacitor VC plus V second resistor VR2. There's no power source or voltage source, so it will be equals to 0. Okay, so now we want to write this equation. Okay, this voltage, the resistance voltage, the inductance voltage, capacitance voltage in terms of the resistance, inductance, and capacitance times current. Okay, and we want to write that in the S domain. Okay, so if you still remember in the slide or in the video where I discuss modeling of electrical circuit. Okay, so if you have resistor, so V of R, okay, yeah, the Laplace transform, okay, of the voltage will be the resistance multiplied by current. If you have inductance, VL will be SL multiplied by current in S domain. And for capacitance, it will be 1 over SC capacitance multiplied by current. Okay, so if I substitute here, okay, this VR1, it will be R1 multiplied by I1 S plus this one, the resistance R2. Okay, now this time you see this R2, this resistance here, both I1 and I2. Okay, so I1 go this way, I2 go that way. So both I1 and I2 are flowing through this resistor, but in the opposite direction. Okay, and this time, since we are writing loop 1, so we will have I1 minus I2, okay, equals to Vi of S. Okay, so I can rewrite this. And let's expand this, and at the same time substitute this R1 and R2 with 1 ohm and 1 ohm. Okay, so here we will have I1 of S plus I1S minus I2S equals to Vi of S. Okay, so here I have 2 I1S minus I2S equals to Vi of S. Okay, so I have one equation. Now let's move here. This is inductance. So we will have SL I2 of S plus this one is capacitor. So we will have C over S I2 of S. Okay, and for VR2 it will be R2. Now this time we are dealing with the second loop. Okay, so we will have I2 of S minus I1S equals to 0. Okay, so we expand this, and at the same time we substitute the inductance, capacitance and resistance with the respected value. So here we will have S I2 of S plus 1 over S I2 of S plus I2S minus I1S equals to 0. Okay, now here we have 1 over S. We want to eliminate this 1 over S. Okay, so what we can do is we multiply everything with S. So here we will have S square I2S plus I2S plus S I2 of S minus S I1 of S equals to 0. Okay, so the multiplier for I2 of S will be S square plus S plus 1 I2 of S minus S I1 of S equals to 0. Okay, so we have the first equation and second equation. Okay, and before we move to the next step, if we examine this circuit, okay, we know that VO, okay, of T is equals to VC of T. Okay, so VO of S is also equivalent to 1 over S I2 of S. Okay, so I2 of S is equals to S VOS. Okay, so this one is equation 3. This one will be useful later. Okay, right. So now we know that we have the relation of the output voltage. The relation is with the second loop, okay, or current in the loop number 2. Okay, so we can use Cramer's rule. Okay, Cramer's rule to find I2 of S in terms of VO of S. Okay, so for I2 of S it will be, so here we write the multiplier for I1. So if you look here, multiplier for I1 for the first equation is 2, and for the second equation multiplier for I1 is minus S. Okay, so sorry, we write here 2n minus S. Okay, and here we want to write the output. Okay, so here we have, for the first equation, we have output of Vi of s. For the second equation, we don't have output, so it's 0. And divided by delta. Okay, so this you multiply, you get 0, minus, you multiply this, you get minus, okay, s Vi of s over delta. So this one is s Vi of s over delta. Okay, so now delta is equals to the multiplier for I1, okay, and multiplier for I2. For the this one, the first equation, multiplier for I2 for the first equation is minus 1. Okay, so if you look back here, multiplier for I2 for the first equation is minus 1. This is multiplier for I2 for the second equation. Okay, so we put it here. So multiplier for I1 for second equation is minus s. Multiplier for I2 for second equation is s squared plus s plus 1. Okay, so now you want to multiply. So here you will get 2s squared plus 2s plus 2, and minus, you want to multiply this. Minus and minus will be positive. 1 times s is s. Okay, so here 2s squared plus this one s plus 2. So this is delta. So we substitute this into here. So you get I2s equals to s Vi of s over 2s squared plus s plus 2. Okay, and if you rearrange, you will get I2 of s over VIS equals to s over 2s squared plus s plus 2. Okay, now the question asks us to determine VO of s over Vi of s, okay, which is output over input. Okay, so this terms is called transfer function, okay, which is the ratio between output and input. And we have from equation number 3, okay, if you remember in the previous slide, we have equation number 3. We know that I2 is equals to S VO of S. Okay, so I replace this I2 here, I replace with S VO of S, okay, over VIS equals to S over 2s squared plus s plus 2. Okay, now if I take this to this side, this s will cancel out. So VO of s over Vi of s is equals to 1 over 2s squared plus s plus 2. So this is the transfer function of the given circuit, okay, electrical circuit, which is and in terms in the S domain. Okay, so this is I think the last video that I prepared for this course for this semester, and with this I would like to wish you all good luck in your final exam. Thank you.